Do you want to learn how to create API stress testing scripts using Gatling in the shortest time possible? Well, you're in the right place. Hey everyone, welcome back to the channel. In today's video, we're going to go through a quick crash course to get you up and running with the Java version of Gatling and get you writing stress tests against a real API application. Now, if you've never used Gatling before, but you're curious to start, or you just want to see what the tool can do, then this is definitely going to be the video for you. By the end of this video, we're going to have built out an entire Gatling stress testing script from scratch. And it will contain many of the different features of Gatling as well. So things like handling different test data, handling parameterization in our script, dealing with things like environment variables, and many other advanced concepts as well. So the content of this video and of this crash course is going to be loosely based on my Gatling Java course, which is available on Udemy. So we'll be flying very quickly through the content and concepts of this video, but if you want a more in-depth introduction to Gatling, if you want more detail on the different concepts that are covered, then I'd highly recommend checking out the course. But if you just want to get started quickly, then this is the video for you. So I've broken this video down into chapters, which should make it easy for you to find the exact part that you wish to refer to. If this is your first time using Gatling, you'll probably want to just watch the video from start to end. But if you've got a bit more experience with Gatling, then do feel free to jump around to any chapter that interests you. I've added the timestamps below for all of the different chapters, so again, feel free to click on those if you wish. There's also a supporting GitHub repository where I've added all of the different code that we're going to write in this video. I'll add a link in the description if you want to check that out. So let's go over some of the prerequisites that you'll want to make sure that you have installed in order to follow along with this video. Now in this video, we're going to be using the Java version of Gatling. So obviously you're going to want to make sure that you have the JDK installed. So for this video, I'm going to be using JDK version 17. Now other versions of the JDK will probably work fine as well, particularly JDK versions 11 and 8, which have both been significantly tested with Gatling. Other versions will probably work okay as well, but just bear in mind that I am using JDK 17 for this video, and I would recommend that you do the same. Now chances are you already have the JDK installed, so to check that you do, just open up a terminal and type java-version. If the JDK is installed, you should get a similar message to the one that you're seeing here. If you don't have the JDK installed, then that's fine. You can just head over to this page here, and then you can just follow the instructions here just to get the JDK installed and set up. Now we're going to be installing the Gatling dependencies and also executing our Gatling script using the Maven build tool. So again, you're going to want to make sure that you have Maven installed. Again, this is a very common build tool, so there's chances are that you already do have this installed. So again, to check that you do, just open the terminal and type Maven-version. If you have Maven installed, then you should see a similar message like this. If you need to install Maven, then just head over to the Maven download page and follow the instructions here to get Maven installed. So we're going to be cloning a GitHub project that contains the initial Gatling setup code. So again, to do this, it would be good if you had the GitHub CLI installed and a GitHub account. If for some reason you don't have those, again, you should be fine. You can either register for a GitHub account or you should be able to just download the repository yourself. But again, having a GitHub account will just make things slightly easier. And finally, it would be good to have an IDE installed in order to follow along with this video. So strictly speaking, you could just use like a text editor, that would be fine, or you could use some other IDE like Visual Studio Code. For this video, I'm going to be using IntelliJ and the Community Edition. So again, if you don't have IntelliJ installed, you can just head over to this page here and you can download and install IntelliJ just by following the instructions on this page. Again, the Community Edition should be absolutely fine for this video and for using Gatling. So with the prerequisites out of the way, let's take a look at the API that we're going to be testing against in this video. So the application that we're going to be testing against in this video is the Video Game DB API. Again, this is an application that I featured in a few of my videos. It's just a very simple API running in a read-only mode, and it's good for learning test automation, scripting, things like that. So we're going to be making most of our calls against this video games controller. We can see here we've got a few different endpoints that we can call to get details of various video games. So we can call this top endpoint here. This is to just get all video games. So if I just click try it out and execute, we can see it makes the API call and it returns this data here, which contains details of a few different video games. We can also call this one here if we want to get details just of a single game. So if I just provide a game ID, say a 4, we then just get back details just of that one specific game. Now there's other calls that we can do here for post, put and delete. So if we tried out the post call, what this would do is it would simulate creating a new game. Obviously to do that we would need to send a blob of JSON up to the post call to create the new game. So if we just try and execute this as it is, we get a 403 error response back. And the reason that we're getting that is because we haven't authenticated with the API yet. So we do have the ability to authenticate with this API as well. So let's see how we can do that. So to authenticate, we open up this authentication controller. We have this call here that we can make to authenticate with our API. So in order to authenticate, we just need to send up a username and password. So our authentication is very simple. It just needs a username and password of admin. So what I do is I'll send up that authentication call, and then we get this response back that contains this token like so. So what I'm going to do is I'm just going to copy that token. So I've just copied that to my clipboard. If I now click on authorize, I can paste that token in, click authorize, and now all of the calls that I make to post, put and delete, these will all be now authenticated. So if I try out the same post call again, so this one again is to create a new game. If I click execute and execute again, I can see this time I'm getting a 200 response back indicating that the game was successfully created. Now just as a reminder, our application is running in a read-only mode, which means no actual game is actually created on the back end. It's just simulating it for our demonstration purposes. So there's other calls in here to update a game and to delete a game. So to update a game, we would just put in a game ID, and again we would just send in our request body. We try that out. So now that I've authenticated, this should work okay. So yes, I get a 200 response back to say that that game has been updated, and we have a delete as well, which works in the way you might expect. So we'll just delete, say, game number 3, and again we get a message back saying that that game has been deleted. Again, because we're running in read-only mode, the game hasn't actually been deleted, we're just simulating that API call. Okay, so this is our application. So it's a very simple API, but it contains all of the different, normal verbs that you would test against: get, post, put, delete, and it's enough for us to be able to write a comprehensive Gatling script. Okay, so now that we've had a look at the application under test, let's go ahead and get our Gatling code project set up. So I've created a simple GitHub repository that you can use for this video, and it contains all of the setup code that we need to get started with Gatling. So if you just head over to this repository here, we can just clone this like so. So I'm just going to click code. I'm going to copy the SSH command here. I've just opened up a terminal and I'm here on my desktop. So I'm just going to do git clone and paste in that command. That's going to clone the repository for us. I'll cd into that folder that we just created. And we can just list the files quickly. So we can see here we've got all of the initial files. So I think what we can do straight away is just import this into IntelliJ. So I'm going to open up IntelliJ now. So I'm here on the IntelliJ landing page. So I'm just going to go to open. I'm going to go to my desktop, find the folder that I just cloned. I'm going to find the pom.xml, press open, and then I want to choose open as project. So IntelliJ is going to go ahead and import the project now, and it's going to download all of the different Gatling dependencies that we need. So let's have a quick look through the pom.xml just to see what got downloaded. So we can see here we've set the JDK to Java 17 because we're using Java 17 for this. We can see here we've pulled in the dependencies for Gatling, a few other different plugins that we need for Maven, etc. And that's about it. So there's not too much to pull in, and this should be enough for us to start writing tests. So just to check that everything's working okay, we can open the source test Java folder. If we open up this computer database, you should see this computer database simulation. So this is an example simulation that just ships with Gatling. It's just a demo simulation that records a user, that replays a user journey against a Gatling application that they host and own. So we can just go ahead and run this. So if we open up the engine class, right click on that and choose run, and then IntelliJ is going to go ahead and run Gatling for us. So we get a prompt at the bottom to enter a run description. So I'm just going to enter test. And because we've only got one simulation, this computer database simulation, Gatling should go ahead and run that. So we can just see if we look at the log output at the bottom, every 5 seconds or so, we get output of the Gatling test that's running against this application. So that should take a few seconds or so to run, and then that simulation's finished. So that means that we know now that Gatling has been installed correctly, and we're ready to now start writing our own Gatling tests. So just to keep things nice and clean, I'm actually going to go ahead and just delete this computer database folder. Just delete that there like so. and I'll close down the other open files that we have at the moment. Now at this point you might want to use the built-in Gatling recorder to record a user journey against your application. If you wanted to do that, you could run this recorder class. So if you run this class here, it will start the Gatling recorder, and then you can use the recorder to record a script step by step. I'm not going to do that in this video because I want to just write out all of the Gatling code from scratch and show you how you can do that. But if you want to learn how to use the Gatling recorder, I did cover that in a previous video, and I'll leave a link to that somewhere at the top here. So before we write out our main scripts, I want us to first write out the most basic Gatling scripts possible. So this script is just going to have three things. So it's going to have, first of all, the protocols at the top where we set up the defaults to be used throughout the script. It will then have our scenario, and our scenario is just going to consist of one single API call. And finally, we'll have the load simulation as well. And again, our load simulation will be nice and simple. It will just be for one single user. So let's create a new package and class and start writing that script out now. So in my Java folder, I'm going to create a new package. I'm just going to give that a name of video game DB. I'll then right click and choose a new SCADA class. We'll give that a name of video game DB simulation. So the first thing we'll do at the top is we'll add the default Gatling imports. So we're adding in here the different dependencies that we need for the Java version of Gatling, and we're also adding a couple of different static imports. This will make it easier for us to write our script without having to call these each time. So it's good to just add these four imports at the top of any Gatling script. We also need to extend this from the main Gatling simulation class, so we'll just add that in. Okay, so let's start off with our HTTP configuration. So we'll say private HTTP protocol builder. We'll just call that our HTTP protocol. Say equals HTTP. Let's go on to a new line. Let's set our base URL. So our base URL is https videogamedb.uk/API. Just check my double quotes are okay. There we go. We're also going to add a default accept header as well. So we're going to send the application JSON header as an accept header with all of our calls as well. We'll just add the semicolon at the end. Next thing, let's add our basic scenario definition. So we're going to say private scenario builder. Private scenario builder. There we go. Just call it SCN. And then we just say scenario. And then we need to give our scenario a name. So we'll give it a name of video game DB stress test. We'll then call an exec block, and it's going to be a HTTP call that we make, and we need to name our transaction. So this is the name that will appear in the report. So we'll just call our transaction get all games. And on a new line, we're going to make a get call, and then we just need to put in our endpoint. So the endpoint here is just video game. Okay, so that's our scenario. So our scenario has just got this one transaction, get all games, and the transaction just makes this call to /video game. Finally, let's add the load simulation. You can spell that, load simulation. So in there we add these curly brackets, we add the setup block. Inside the setup block we say scn inject open. We're just going to do @once users and just one single user. We need to tie that to our protocols as well. So we just call protocols and the HTTP protocol. Just finish that off with the semicolon. So that's our basic Gatling script created. So it just contains the HTTP protocol, which contains the defaults. We then have our load scenario, which is just calling a single endpoint. And then we have our load simulation defined as well, which just runs our load test with just a single user. So we can run this script now. So I'm just going to run the engine class. So if I double click on engine again, and I'll just right click and run that. So again, IntelliJ is going to go ahead and fire up Gatling for us. We'll just enter our run description, and we should see our test run through straight away. It looks like the test is running fine. It's just making that single call to that one endpoint. Okay, so we've got our really basic script now, and what we're going to do from here is we're going to build this out to make the other different API calls. So if you remember, we had calls to get all games, and we had calls to do a post to create a new game, to delete a game, etc. So what we're going to do is we're going to include all of those different calls in a script and make a more realistic and robust script. So let's go back to our scenario and let's just write out in using the comments the different calls that we want to make, or to the different endpoints. So the first call that we're going to make is to get all video games. We're then going to want to create a new game, but before we can do that, we will need to authenticate. So if you remember when we were playing around with the application before, we saw that if we wanted to create a new game, we'd need to authenticate first. So the second thing that we'll do is we'll do the authentication, and we'll see as well how we can handle getting that token back and saving that in our script, and then using that later on to make subsequent API calls. So once we've authenticated, we can then create a new game. And after that, we're going to get the details of the newly created game. So we're just going to get the details of that single game that we've just created. And finally, we'll just delete that newly created game as well. So what we're going to do for each of these different API calls is that we're going to create a method that's going to hold each of those different calls. So what this will do is that once we've created each method, we can then call that method whenever we want to make that API call. If that doesn't make sense, don't worry, let's just follow along with the code and you'll soon see what I mean. So let's just make a comment here that where we're going to add in the HTTP calls. So the first one here is going to be where we get all of the games. So we'll say private static chain builder, and we'll just call our method get all games. So in that get all games method, we can just do exec HTTP. Again, we need to name our transaction. So as before, we'll just name this one get all games, and we'll just do a get, and then that's to the video game endpoint. So again, this is exactly the same as what we'd written down here, but all that we've done now is that we've just put this into its own method. Let's add another method, this one for authenticating. So again, we'll just do another private static chain builder. We'll call our method authenticate. So again, it's an exec HTTP. We're going to name our transaction authenticate. So this authenticate transaction, this is going to be a post call, and the endpoint that we're calling is the authenticate endpoint. And when we're calling authenticate, we need to send up a body. So we're going to say body and string body. And let's see what body we need to send up. So if we go back over to our Swagger, if we look at the post again, so the request body, when we're making this call to authenticate, this is the body that we needed to send up. So let's just go ahead and copy that. I'm going to paste this inside the string body like so. So now that's sending our string body that's got our username and password of admin. So just after the second quote, I'm going to add a new line, and I'm going to add a check. And what we want to do is that we're going to want to extract this token that comes back. So if you remember, when we call this endpoint, we get back this token in our JSON response. So what we're going to want to do is we're going to want to save this token within our Gatling script. So the way that we can do that is with a check. Inside that check, we're going to have a James path. Our James path is simply going to be token, and we're going to save that token as, we'll just save it as JWT token, add our semicolon at the end. So again, this James path from token, if we just take a look at our JSON that we're getting back, that's saying it's just looking up this JSON here at token, and then just to grab this value. So it's going to save that value into this JWT token parameter, and we can then use this parameter throughout our Gatling script. Okay, let's add our next method. This is for creating a new game. So we'll do private static chain builder, call this one create new game. This one's going to be another exec. Our HTTP transaction will be called create new game. It's going to be another post for creating a new game. And again, we're going to be posting up to the video game endpoint. Now, when we post to this endpoint, we need to authenticate with our API. So to do that, we need to add an authentication header. So we'll say .header. Our header's called authorization. Make sure I spell that correctly. Authorization. So it's our authorization header. And then the value of our header is bearer, and then we use the parameter that we saved previously. So we do hashtag open curly brackets JWT token. So again, we're sending a header here called authorization, and our authorization header is the text bearer and then the JWT token. So again, if we just go over to Swagger quickly, if we look at where we created the new game, if we just test that out, you can see here that we're sending up this header here when we're creating a new game. So we have a header of authorization, of bearer, and then of that token that we saved when we authenticated with our API. So that's what's going on. So just in between the two brackets here, I'm going to add a new line. And again, of course, we also need to send up a body as well. So we call body, and we say EL file body. Now EL stands for Gatling expression language. So we say EL file body. So what we're going to do is we're going to put this body into a template file that we're going to create in just a moment. So we're going to put that file in a directory called bodies, and then we'll call that new game template.json. So again, we're going to create this in just a second, and we want to make sure that we send this as JSON as well. So let's create this bodies new game template JSON. So here I'm going to open up the resources folder. I'm going to right click on there, create a new directory, call that bodies. Within bodies, I'll create a new file, give it a name of new game template.json. Make sure I've definitely got a dot there. There we go. For our new game template, JSON, this is the JSON that I'm just going to paste in. So this contains all of the different fields and values that we need to create a new game just in a JSON form. So again, when Gatling makes this create new game requests, it's going to take that body from the body's new game template, this one here that we've just created, and it's going to use that as our body. Let's keep going with our last two API calls. So we're going to make another public static chain builder. This one's going to be called get last posted game. So this one would have another exec http. We'll name the transaction get last posted game. This one's going to be a get call. It's going to be to the /video game endpoint. And this time we need to specify a video game as well. So for now we're just going to hard code the game. So we could hard code any game ID here. For now we're just going to hard code a value of 1, but we'll change this later on to a parameter. But for now we'll just hard code this as a number. Add our semicolon here to close off that method. And we'll add one final one here, public or private static chain builder. This one's going to be delete last posted game. Add another exec http. We'll call this method delete game. And this time we're going to call the delete method. Again, we'll say the video game endpoint. And again, we're just going to hard code the game here that we want to delete. So in this case, game number 1. Again, we'll change this to a parameter later on. And when we're deleting a game as well, we need to make sure that we authenticate. So again, we'll call our header here to send up the authentication header. So we'll make a header called authorization. And as I'm typing this above, I can see that I've misspelled authorization here above. So I'm just going to correct that. So we'll say authorization, and again, we'll just use the same JWT token. So one other thing that we'll want to add here quickly, in our post call and our delete call, when we're calling the video game endpoint, we're going to want to make sure that we have a header for the content type being application JSON. So we could either do that as adding that in as headers here individually, or we could just set that as the default so that that content type header gets added to all of our calls. So I'm just going to go ahead and add them to all of our calls just to make it a bit simpler. So just in the HTTP protocol, I'll add a content type header, and this one will be application JSON. So again, we're setting two different default headers here, the accepts header and the content type header. Those are just being set up in our protocol at the top. So if we go down now, we can see that we've got 5 different API calls to define. So we've got get all games, authenticate, create a new game, get the last posted game, and delete the last posted game. So the last thing that we need to do now is we need to just hook this up into our scenario. So at the moment, all that we're doing is we're just making this call to get all video games. We're not actually using any of the methods that we just created. So what I'll do is I'll delete what we've got already and then just start from fresh. I'll add an exec block. The first call that we'll make is to get all games. We'll then add a pause time. So let's just pause for 2 seconds. Then add another exec block, this time to call the authenticate call. Add another pause of a couple of seconds. We'll then call create new game. Another pause of 2 seconds. Another call to get last posted game. Another pause of 2 seconds. And finally, we'll make the call to delete the last posted game. And we'll add the semicolon at the end to signify the end of the scenario as well. So our load simulation at the moment is just set up for a single user. We'll just leave that as is. So we can see in our scenario now what we're doing is we're calling each of the methods that we defined above. Those are all part of our scenario now. So our scenario now is very easy to read. We can see exactly what the virtual user is doing. It's making a call to get all games, pausing for a couple of seconds, then authenticating, creating a new game, getting last posted game, etc. Okay, let's go ahead and run the script. So I'm just going to click play next to the engine. We'll enter a run description. Our script has started running through it. You can see it's making the different calls. It's made the calls to get all games, authenticate, create new game, etc. So that's good. Everything looks to be working okay. Okay, so we've got a really basic script created now, but we can see that we've hard coded all of the different parameters. We're not doing any parameterization in our script yet. So what we're going to do now is we're going to add in a feeder, and that's going to allow us to add more different test data to our Gatling script. So let's see how to do that now. So I'm going to go up to the top of the script here, just under the protocol. And here we're going to add our feeder for test data. So for our feeder, we just call private static feeder builder. And we're going to use a JSON feeder. So what we'll call file based. We'll say it's going to be an object because we're going to be using a JSON object. We'll just call it JSON feeder. So we're going to say JSON file. And our JSON file is going to live at a folder called data that we're going to create in just a moment. We'll call it game JSON file.json. And for our feeder strategy, you can see here we've got a few different options: random, circular, queue, shard, shuffle. So again, you can read about these different options in the documentation or in the Java Gatling course. For our feeder strategy, I'm just going to choose random. So that's just going to take a random entry from our JSON file. So speaking of which, let's go and create that JSON file now. So again, in the resources folder, I'll right click and choose a new directory. Give it a name of data. Within that data directory, I'll right click and choose a new file. I'll give the file a name of game JSON file.json. And I'm just going to paste in my JSON file like so. I'm just going to correct a couple of these IDs. So this big JSON file, this just contains JSON that contains the test data for all of our different games. So because we're using a random strategy, what happens is that each time Gatling iterates through, it will randomly select one of the JSON objects that contains all of the different test data, essentially. Okay, so we've got our JSON feeder created. So all that we need to do now is hook that back up into our script. So if we go down here to create a new game, this is where we first want to call the JSON feeder. So we'll just say feed, and then we just need to point to that JSON feeder. So we'll say feed JSON feeder, and then we just need to add a dot on the next line. So when we call the create new game method now, it now calls this JSON feeder. So when it calls the JSON feeder, that's here, then we'll get all of this different test data. So these parameters will all then become available to us. So we'll have parameters for the ID, the name, the release date, the review score, etc. And they'll all correspond to whichever row's been selected or whichever game has randomly been selected. So we can actually start using some of this test data. So let's use it first of all in our transaction name. So instead of just printing out create new game, we can actually print out the name of the game that's being created. So to do that, we just use hash curly brackets name. So again, this name, this is going to be replaced by whichever name has been selected. So whichever name gets selected. So for example, if Gatling randomly selects game number 6 for this block, then that name parameter is going to correspond to Doom. So the other thing that we can edit now is our new game template JSON. So if you can see here at the moment, our new game template JSON looks like this, and we've hard coded all of the different data. So instead of having these all hard coded, we can actually replace those with the names of these parameters. So if I replace them with the parameters, instead of looking like this, it will look like this. Just correct the indentation there. So again, let's go through what happens. So when we call this new game template JSON here, when Gatling calls this line here, it goes into the new game template and it will replace all of the different parameters. So for example, the name, the release date, the review score, etc. These get replaced with these parameters here, which then contain the corresponding test data. Okay, if we go down to the last posted game, so instead of just calling the transaction last posted game, again, we can still use that test data that we've now got available. So we can actually put the name of the game into our transaction name. So now instead of having the game ID of 1 hard coded, we can actually use the game ID. So again, this game ID is going to correspond to whichever ID has been selected. And we can actually add an additional check here as well, just to make sure that we've deleted the game that we expect. So to do that, we'll do a check on the James path that comes back. We're going to say look up the name in the JSON that comes back and say check that it is or is expression language. And we want to make sure that it matches to the name of that game. So it's going to match up to the same parameter. So again, if I just jump over to Swagger to show you what I mean. So if we just say when we're getting a single game, so say we're getting game number 4, what we get this response back. We'd get a name of our game. Our name would be Super Mario 64. So Gatling's going to take that name. It's going to take that name. It's going to say, okay, the name of the game is Super Mario 64. And what it will do is it will then check our name parameter. A name parameter will then come from here, and it will make sure that those match, just to make sure that it's got the same name. So if those match, then the check will pass, and then the Gatling test will continue to execute. Otherwise, we'll get a failure at this point. Let's go down and parameterize delete game as well. So again, I'm just going to add in the name of the game here. So do hashtag name. So we print that out in the transaction. Instead of hard coding game 1, we're going to want to have the ID of the game. And let's also add a check to make sure that we get a message back saying that the game was deleted. So we'll add a check for the body string. And then I think the text that we get back when we delete a game, let's just check. The text we get back is here, this video game deleted. I'm just going to grab that, paste that in there like so. Okay, so we've added a few different checks to our scripts and we've added in some parameterization as well. Let's go ahead and run the script again just to make sure it's still working okay. So I'm going to run the engine class again. I'll enter my run description, give that a few seconds to run. It looks like the test has run okay. So you can see this time when we're calling the transaction for creating a new game, it has the name of the game that's been randomly selected in there as well. And we can see all of our transactions have passed, which means that our checks and our assertions must be working okay. Okay, so we've now got a Gatling script that's got some parameterization in it as well, and it's got different test data in there as well. So what we're going to do now is we're going to add in a proper load simulation. So far we've just been running through with a single user. So now we're going to add in an actual load simulation with multiple different users. So let's see how to do that now. So if we go down to our load simulation at the bottom, so after inject open, I'm going to take out this at once users. I'm going to add a new line. So the first thing I'm going to say is do nothing for 5. So this will just do nothing for the first 5 seconds. So it just gives the test a chance to warm up. We'll add a comma, and then we're going to say ramp users. Now we could just hard code in a number of users here. That would be fine. But what we're going to do is we're actually going to use a runtime parameter for this. So we're going to enter a parameter called user_count. We're going to define that in just a moment, and we also want to make sure it ramps during a period. So again, we could just hard code in a period here, like 30 seconds or 45 seconds. But again, I want to use a runtime parameter for this. So I'm going to say, for my parameter, I want to call it ramp duration. So let's go up to the top of the scripts, and then let's add in those runtime parameters. So just under the HTTP configuration, I'll just add in the runtime parameters. So the first one is a private static final int. This one was for the user count. So for the user count, we're going to say integer parse int, and then we're going to say system.getProperty. We'll call our property users. And if no property is defined, then we're just going to default that to 5. So I just need to make sure that my brackets are correct. So I'll add the default of 5 in there like so. I'll make sure that 5 is a string. And we'll do the same sort of thing for the ramp duration as well. So I'm just going to copy the user count. I'm just going to change the user count, change it to ramp duration. This one we'll call ramp duration, and I'll set that as a default of 10. So what we're going to do in a moment is we're going to run our script through Maven, and when we run Maven, we're going to supply these parameters at the runtime. Now, the point of doing this is that it means that when you come to run your Gatling tests in production, you can add in these different parameters straight into your script instead of having to edit them in the script. So it's a really common way of adding flexibility and dynamicness to your Gatling scripts. So back in the script, if we just go down to the load simulation at the bottom, so we can see we've got a pretty simple load simulation. It's going to do nothing for the first 5 seconds. It's then going to ramp up to our number of users during the ramp duration that we set. So if we set this user count and this ramp duration, it will change to those parameters. Or if we don't set them, it will just go to these defaults of 5 and 10 respectively. It might also be useful to add a message to see what these parameters are getting set to. So in Gatling, we can do that with a before block. So I'm just going to add this here just above the HTTP call. So for that, we do a public void before. And for this one, we need to override the method because we're adding in our own logic. So for this, we're just going to say system.out.printf, and then we're going to say running test with %d users. Add in a new line as well. Then our users are just going to be whatever our user count is, and we'll print out a message for the ramp duration as well. So let's say ramping users over %d seconds. Change this user count, change that up to our ramp duration. There we go. Okay, that looks good. I think we can go ahead and just run the script now. So we're just going to run it through IntelliJ. So we're not setting those runtime parameters, so they should just default for us. So again, we get a message here printing out saying running with 5 users, ramping over 10 seconds. Okay, so our stress test is running through now. And we can see here, if we look at the report that's getting generated, we can see how we're making requests to different games and how those are being parameterized in our test report as well. So we know that our parameterization is working. So that's how to run it through the IDE. Let's see also how to run it through Maven. So if I just go over to a terminal, I'm just going to do Maven Gatling : test, and then pointing to our video game DB simulation. So I point to the video game DB package, the video game DB simulation, and this time I'm supplying different parameters. So I'm providing a parameter for 10 users, and I want it to run I want the ramp duration to be 20 seconds. So I'm going to go ahead and press enter. Maven's going to run our Gatling test for us. We can see this time that we've changed to 10 virtual users ramping over a period of 20 seconds. So you can see how we've added in parameterization to our test. So without having to change any of the code in our test, we can change the number of users that we're running with, which is really cool. So we'll give our test a few seconds to run through. We can see all the details of our transactions are being printed out like so. And then once the test finishes, we get information that the test is finished, and we get details that the test report has been added to this location. So what we can do now is we can open up this test report. So we can either look for this in our file system, or we can open this directly in the IDE. So if I just go into the target folder, open up the Gatling folder, I'll open up the last simulation run, find this index.html, then just choose open in browser. I'll choose Chrome. And then when we open it up like that, we can see that we get the graphical Gatling results report. So this results report contains all of the details from our load test run. So we have details here of all of the different transactions. And then we get some metrics as well on our load test. So we see the number of active users during the simulation, the distribution of the response times over time, number of requests, responses per second, etc. there. This is also broken down by each transaction type as well. So if you wanted to just look for a particular transaction, you can see the breakdown for that individual transaction. Or if you click global, you can just see the stats for all of the different transactions put together. So in this crash course, we've seen how to create a Gatling API stress testing simulation. And we covered a lot of the fundamental concepts of Gatling script creation. This video should give you a good starting point for writing your own Gatling stress tests. In terms of next steps, I would really recommend checking out the excellent Gatling documentation. The Gatling community forum is also a great place to hang out and post any questions that you have relating to Gatling. For a more comprehensive introduction to Gatling, I do have a number of Gatling courses hosted on Udemy. In my Gatling Java course, for example, we go through all of the concepts covered in this video, but in much more detail. I also have an advanced Gatling course where we cover creation of an entire Gatling stress test framework from scratch, and we use that to load test a real-world e-commerce application. So do check that out if you're interested to learn more about Gatling. As always, if you have any questions, just let me know below. But otherwise, see you in the next one.